You ever feel like math is just, a bunch of random numbers on a page? Well, today we're going to prove that wrong. We're turning some tricky math problems into exciting, real-world puzzles that you can actually solve. Okay, let's dive into this. All right, take a look at these two tigers. One looks absolutely perfect, right? Powerful, majestic, exactly how a tiger should look. The other one, yeah, something is definitely off. It's all stretched out and weird. So what's the big difference here? The answer is a super powerful idea called proportionality. Proportionality is really just the secret to keeping things in balance. Think about our tiger picture again. To keep it looking right, if we make it wider, we have to make it taller by the exact same amount. It's this rule that makes sure everything looks fair, balanced, and, correct. So here's our game plan for today. We'll start with this big idea, then we'll get our hands on a master tool for solving these puzzles, and after that, we're going to tackle 3 rounds of challenges. Let's do it. Okay, so we get the what. Now let's get to the how. To solve these proportionality puzzles, we're going to learn this brilliant little shortcut that's been around for literally centuries. It's called the rule of 3. And check this out. This rule of 3 isn't some new trick. It is ancient wisdom. The great Indian mathematician Aryabhata was talking about this method thousands of years ago. It's a totally timeless tool for figuring out a missing piece of the puzzle when you already know the other 3. And that ancient rule, it's actually super simple to use today. It really just boils down to 3 easy steps. First, you set up your 2 equal ratios with your mystery number, x. Second, you do this thing called cross multiplication. And third, you just solve the simple little equation that's left. Let's see it in action. All right, our first challenge round is all about things that change over time. We're going to deal with everything from a person's age to how fast a tractor can plow a field. Okay, let's help Harmain and her brother peek into the future. Right now, she's 1 and he's 5. What we need to find is that exact moment in time when her brother is exactly twice as old as she is. So for every 1 year of her age, he'll be 2. And here's how we crack it with our 3-step method. Let's just call the number of years that need to pass x. So Harmain's future age is going to be 1 plus x, and her brother's is 5 plus x. We set that up as a ratio equal to 1 over 2. We cross multiply, and we solve. And what do we get? X equals 3. So in 3 years, Harmain will be 4, and her brother will be 8, a perfect 1-to-2 ratio. Next up, a classic problem you've probably wondered about yourself. We know how fast it takes to fill a little mug, but what about a big, big bucket? We can use proportionality to figure it out without just standing there with a stopwatch for ages. Now, the absolute key here is making sure our units are the same. You can't compare milliliters to liters directly. That's a trap. So first, we convert 10 liters into 10,000 milliliters. Now we can set up our proportion, solve for our unknown time, and boom. The answer is 300 seconds, which is exactly 5 minutes. Simple as that. And now for a race on the farm. We're pitting old-school animal power against modern machinery. We've got a huge 20-acre field to get through, so let's figure out the time for both the oxen and that speedy tractor. Let's start with the oxen. It takes them 6 hours for just 1 acre. So for 20 acres, we just multiply 6 by 20, which gives us a whopping 120 hours. Now the tractor is 4 times faster, so we just take the oxen's time and divide it by 4. 120 divided by 4 is 30 hours. Yeah, that's a pretty clear win for the tractor. So we've seen how this works with time. Now let's switch gears and see how it applies when we're scaling things up. We're going to be thinking about size, week, and area. Everything from a tiny bit of precious metal to massive farms. We all know gold is heavy, right? But how much heavier than something like water? This ratio right here gives us the clue. It tells us that if you take the same amount of space, gold has a mass of 37 units for every 2 units of water. Let's use that to find out what a liter of gold actually weighs. So we set up our proportion. 37 is to 2, just like our mystery weight of gold is to 1 kilogram. A quick calculation and wow, a single liter of gold has a mass of 18.5 kilograms. To give you an idea, that's like trying to lift more than 18 of those big cartons of milk at once. Okay, time to help a farmer out so he can grow some amazing tomatoes. The recommendation is in tons per acre, but his land is measured in feet. So our first job is to figure out the size of his plot in a unit we can actually work with. First things first, we got to do a little conversion. The plot is 200 feet by 500 feet, which means the total area is 100,000 square feet. Okay, and we know that 1 acre is exactly 43,560 square feet. Now that we have these two numbers, we're ready to solve this thing. So by dividing the plot's total square footage by the size of an acre, we figure out the farmer has about 2.3 acres. And since he needs 10 tons for every single acre, we just multiply those numbers together. Looks like he'll need to buy around 23 tons of manure. All right, for our final challenge, let's put on our detective hats. We're going to take a look at something you might have in your pocket right now, a 10 rupee coin, and figure out what it's really made of. And, more interestingly, what that stuff is actually worth.
So, a 10 rupee coin isn't one pure metal. It's a mix called an alloy. And the recipe is pretty simple. It's a 3-to-1 ratio of copper to nickel. That just means if you could break the coin into 4 equal parts, 3 of those parts would be copper and 1 part would be nickel.
So first we use our ratio to split up the coin's total weight of 7.74 grams. 3/4 of that is copper, and the other quarter is nickel. Then we look up the current market price for each metal per kilogram, and from that we can calculate the cost of that tiny, tiny amount that's inside the coin. So what's the grand total when you add up the value of the copper and the nickel inside a 10 rupee coin? The raw metal is only worth about 8 paise. That is less than 1/10 of a single rupee. It really shows you that the true value of money is in what we all agree it represents, not what it's physically made of. So there you have it. From stretched out tigers to the real value of a coin, proportional reasoning is like a secret key that helps us make sense of the world. It's the hidden logic behind cooking recipes, building designs, and so much more. Now that you know its secret, keep an eye out for it. Where do you think you'll spot it next?